This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast. Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the Uptime Podcast, bringing you the latest in wind energy tech, news, and policy. All right, welcome back to the Uptime Podcast. I'm your co-host, Dan Blewett. On today's show, we are going to talk a little bit about the construction process and some of the things that can go wrong, unfortunately. We've got a recent story of a train colliding with a truck carrying a wind turbine blade. So this is obviously bringing a big spotlight to, just some of the difficult logistics and the overall sort of construction environment where there's so many pieces involved, so much going on. So we'll talk a little bit about that today. We're going to talk a little more about wind turbine blade recycling. Vestas has an initiative, as does Siemens Gamesa for the future. We'll talk about the Jones Act as it's dealing with offshore wind, some seafloor mapping drones, and a little bit about this offshore open hydro tidal turbine that's now being removed from the ocean. And before we get going, I just want to remind you that in the description of this podcast, you'll find Uptime Tech News, which is our weekly newsletter update for our podcast and other great news around the web. So if you want to stay updated with everything, definitely jump into the links, whether you're on YouTube, Spotify, iTunes, Stitcher, and sign up for Uptime Tech News. Like I said, we want to keep you updated. That way you have a great newsletter from us every Thursday morning, depending on where you are in the world, just to keep you up to date. And you'll also find Rosemary Barnes' YouTube channel, where she's continuing to put out great renewable energy content. So Rosemary and Alan are here with us. So let's start with this train. Rosemary, how did you feel seeing this train collide with this poor wind turbine blade driver?
Yeah, I felt really sick. And in the first view of it that I watched, the guy who's taking the film is just going, "Oh my God, oh my God, oh my God." And that is like exactly mirrored what I was saying in my head. So I can't imagine what the truck driver was thinking as, he's trying to get out of there and then the train comes. And then Alan was kind enough to send me a second angle of it from behind. So, I really got the full 3D effect, and it's just absolutely shocking, isn't it? But I was so happy to see that no one was injured. Somehow no one was injured in that accident, except for the, poor wind turbine blade, but that can be replaced at least.
You'd think most of these things, when they're transporting such a big blade, obviously they have like these couple cars that trail them, like these flag cars. It's a really big process getting them moved. Why did this even have a chance of happening?
Well, just looking at the map of Texas where this event happened, it's a smaller town, and what it looked like they were trying to do was trying to get from one highway to the other through town. And the way that town was constructed, there's some gas stations and some obstacles right along the corner, so it's very hard to kind of make the turn on the proper road. So what it looked like they were doing was kind of going behind the buildings, kind of squirting behind the buildings next to the railroad track, and then cutting across the railroad tracks to get back on the road again. And just bad timing. I think either they didn't know what the train schedule was, or they hadn't arranged it with the train guys, and timing was everything. You could see in the video, you can actually see the crossing guards start to close, and everybody around there can hear the train coming. In Texas, you can hear them for miles and feel them too. And so they knew it was going to happen. And I was a little shocked that the trucks didn't start moving a little bit sooner. They knew that was coming, or maybe he didn't know it was coming. But it seemed like at the last second, he put some gas in the semi and pulled it forward, which is probably the best scenario. It probably actually saved some lives, honestly. Because where the train hit that wind turbine blade was close to the end. If they had hit it like square in the middle, you could have had a train derailment. It could have been a lot worse. So even though it was a bad situation, this is actually not as bad as it necessarily could have been.
Yeah, and I could have seen like the blade, the way it bent when it hit, because obviously it's meant to have a lot of flex in it, or at least some degree of flex. I mean, if it hit in the center, it could have been 50 meters of blade, like essentially like wiping out the people, like flinging them aside essentially off, like, you know, and just crushing anything on both sides of that track. So
it's so heavy, yeah. Then the images of the train hitting, it looks like it's tossed like it's a vehicle, and that piece of blade weighs more than a vehicle does. And it whatever it hit afterwards, I'm sure there's damage to buildings down along the railroad tracks. It looked like there was some closer buildings along the railroad tracks further down. So there's a whole bunch of cleanup to do, and you know, in the state of Texas, there's going to be a lot of oversight about this to try to figure out what happened and try to get safety bulletins out and make sure everybody had the proper licenses and authority to be there, and two, trying to make sure that doesn't happen again.
So Rosemary, when a blade leaves the factory, I mean, what are the next steps? I'm sure a lot of it's just like mundane stuff, like paperwork and, you know, getting where it needs to go. But there's probably been a big evolution just how these are carted off, hasn't there?
Yeah, well, I've actually had like more experience than I'd like with the logistics departments who take care of what happens to the blade after it leaves the factory, because every blade that I was working on was a prototype blade, right? So we're doing something for the first time in there. And the logistics team want to know exactly when it's leaving the factory. Normally they do, and they precisely plan a route so that, you know, they can arrange for train crossings to be closed and that sort of thing. Also, they're trying to get, you know, cheap rates on ships. If you just, you know, show up and want to get on the next ship, that's a lot more expensive than if you can slot into something that's got a little bit of space free. Yeah. So if, for example, you're involved in a project that was supposed to be finished in, you know, like the end of July, but you've got problems and then, you know, it's pushing out a week, then you're definitely going to get the logistics team from your customer calling you very frequently to find out exactly what day your blade is going to be leaving. So, yeah, that can be pretty stressful. And then I have to say, on the projects that I worked on, I don't know, people started to think that I was cursed, because every time that I would be working on putting up a prototype wind turbine with some new product on it, something would happen. So I saw blades that got, because I was always going to snowy areas where the roads are icy at the, you know, you're trying to get in before winter, but of course the schedule blows out. So you're always arriving just as winter's starting. Roads are icy, big trucks. Someone always drove a blade into a ditch. That just constantly happened. I also experienced accident, like in the port, blades waiting in the port. Someone drives a truck or a forklift into it, and it's like, oh, we'll get another one. Oh, we don't have another one because this is a brand new prototype blade and we only made 3. Man. I even saw something fall off a ship. A container fell off a ship one time on a project I was working on. And it's like, it had like a 6-month lead time, this thing that fell off the ship. And it was like, how? And yeah, so it did really start to feel like I was cursed, because it's like you got enough problems of your own, you know, when you're trying to develop a new technology. You've got technological problems that you're trying to fix, and then, you know, that so much can go wrong. I don't think it's normal that as much goes wrong as what I experienced personally, but yeah, definitely. I imagine, I wonder if this is a prototype blade and there's someone, you know, just like me sitting there going, why did this happen? Yeah.
Yikes. That's crazy to think. I mean, obviously, like, a lot of the stuff is in the news and, you know, some of it's not, but there's so many of them out there that these things are going to happen. So there's an interesting article on wind power engineering recently about not a super exciting piece of technology, but this ERIC inflatable cover that goes on the top of wind turbine towers as they're being constructed. You know, like with construction, you see when there's a huge storm, these poor construction sites are just like muddy and soaked. But I mean, how much of these towers as they're going up and like the blades in transport, how much of them are sensitive to the elements, Rosemary? Like how much do they need to be protected to be like, look, we don't want any issues 10 years down the road. So, you know, do they have to really work hard to waterproof these as they're in transport? Like, do they need to be heavily wrapped up? Like, what are some of the kind of the behind the scenes as far as protecting a whole construction site or the blades from Mother Nature?
Yeah, well, so they'll often cap the end of the blade with something so that water doesn't get in, but it does actually cost some money to, install, they call them tarpaulins, or actually the Danish accent was always a tarpaulin.
Tarpaulin, okay.
Tarpaulin. I thought for a long time I was like, oh, it's some sort of combination tarpaulin, trampoline, but actually it was just that, English wasn't anyone's first language, and that's how they were pronouncing it. It was very cute. They cost a bit extra. A lot of customers don't want them. So then you see like little bits of rust, because even if you've got stainless steel for the metal components, you still get some rust, especially surface rust. And then the stuff I was working on always had electrical equipment inside it because it was heated blades. And then you definitely want to cover them up because otherwise, they just get filthy aside from anything else. And also, these wind turbines are designed for onshore, or the ones I was working on. But they're going on a ship first, probably. So they're there exposed to a lot of salt sea spray, but they're not designed to, withstand those really salty environments. So it is actually a bit of a challenge to it's designed for its operational life, but you've also got to make sure it survives its transport life. And I guess that they're experiencing similar issues with the towers. But I was surprised to see that they need a roof because they've got a door at the bottom. It's not like they're going to fill up with water, But it must be a problem. Otherwise, we wouldn't have this solution.
Offshore is the biggest thing ever right now, right? It's booming. So more and more blades are going to be carted farther and farther offshore. So there's probably just going to be a big influx of these sort of protective technologies. Is that something you see was probably just going to be necessary? Because especially if they're taking blades out there and then there are some delays or this and that, there's going to be probably more blades waiting in inhospitable areas. Am I kind of on track there?
Yeah, I think so. And I don't have direct experience with offshore yet. I hope to get some, because I think we've got some projects coming up in Australia in the next few years. But in a way, it would be an easier problem because all of the materials are already need to be up-spec'd a lot to go offshore. So, they're like, if they've got steel, then it's going to be a really high-grade stainless steel. And it's also very obvious to everybody that it needs to be protected. Whereas with the onshore stuff, like there was a lot of times when customers are like, we don't need this. It's for, it's for onshore, and then we would get surprised.
So like that, it'll be fine effect is probably not in play as much for offshore. Everyone's probably like, we need to make sure it's like one and done and we're not having any problems. Moving on. So we've been talking a bunch about recycling recently. Obviously, we had Chris Howell from Veolia on the show talk about some of the awesome things they're doing. But there's a lot of recycling in the news cycle right now. Siemens Gamesa is targeting fully recyclable wind turbines by 2040 and fully recyclable blades by 2030. Vestas is also, right down the same path. Everyone's got their own initiatives, it looks like. But Alan, I'll toss this to you first. One of the things Vestas is interested in doing, and they say they can do this with the CTEC solution, which that's CETEC, but they're trying to chem cycle some of these epoxy-based materials, like obviously like wind turbine blade, and to process them down and essentially reutilize them on like a molecular level. So obviously both of you have talked before about, epoxy resins and thermosets, like when they cure, they chemically change and you can't just melt them again. Like they're just different, right? They're not like a plastic that melts and then can just solidify. So this idea of chem cycling, that sounds kind of, I don't know if counterintuitive is the word, but it sounds like this hasn't really been done before. Alan, is this something that's going to be viable?
Well, I don't know yet. That's the interesting piece about it. I tried to dig into this a good bit over the last week or so to see what the engineering is behind it, and I didn't really see a lot. It sounds like Olin, which is a thermoset manufacturer, epoxy manufacturer, is saying that they can essentially undo the cross-linking that happens in epoxies that makes it so hard and tough and durable. They can somehow break those bonds and bring them back into their constituent parts that doesn't make a lot of sense because no one else on the planet is doing that. So maybe they have some unique chemistry that allow them to, I don't know, hit it with a laser or hit it with some special heat source or something of the sort to break the chemical bonds and get the pieces back, because there is this weird chemical change that happens. So the technology is interesting, but no one's talking. And I even did a quick search of patents to see if anybody had, even slipped and maybe put an application, and I didn't see anything there either. So I don't know if it's real technology. Is it still in the laboratory, as the UK people would say, or is it just something that has been there the whole time and we just haven't paid attention to? I'm not sure where this technology is right now. Rosemary, do you have any idea where they're going with this?
Well, yeah, they told you. You missed it. In the infographic, there's a little pair of scissors next to a polymer. So they've got very tiny scissors, and they're getting in there and snipping those crosslinks. But I just love that. I mean, there's a lot of words in the announcement, and yeah, like it is absolutely a revolutionary thing. And they're like, oh yeah, we disassemble the epoxy. That's like step one. And then they talk a lot about a lot of other stuff. I'm like, wait a minute, you disassemble the epoxy? Like, please go on, because yeah, obviously that's the crucial step that no one's been able to do. And I think I described it the last time we talked about thermosets. I said, like it's like trying to unfry an egg. There's a reaction that's happened that's not so easy to undo. And I don't know where they're at to. Sometimes people, company PR departments want to announce things very early, so perhaps it'll go nowhere. But I mean, I really hope that it is going to go somewhere, because if you can disassemble an epoxy after it's set, then yeah, we can recycle any kind of composites, and that includes the 95% of composites that don't come from wind turbine blades, that come from, aeroplanes and cars and boats and sports equipment. So, like it's way bigger than the wind industry if we can disassemble epoxy resin now.
Yeah, how come Elon Musk hasn't talked about this? Because they would love to use some composites in their cars, and we use composites in aerospace all the time, probably way too much, honestly. And we don't really have a way to recycle them. So if that technology is here, then someone needs to speak up, because you're right, 95% of those composites, epoxy things are getting ground up or put in a landfill. That's where they're going. So let's go. Well, let's see what this technology is. And I just haven't seen anything. It's just crazy.
Well, I guess one of the follow-up questions is, would this end up, and I'm sure we're just speculating, but would this end up cheaper than other forms of recycling it? Like, we're always going to need cement, which is, what Veolia is doing. Is it going to outcompete grinding it up and turning it into cement, or, burning it in the cement kiln, or I don't know what other methods of recycling there might be for it, but does this sound like something that would be really expensive, or does it sound like once the breakthrough is here, it might be really, really easy and inexpensive?
I mean, I've got literally no clue. It could it could be incredibly expensive, or it could be incredibly cheap, because it's really like, I don't know, you might as well say that we have invented a time machine, for as much clue as I've got on how they're actually going to do this. So maybe it'll be.
The cost may not matter too much, because like in Germany, where they've outlawed the burying of wind turbine blades, then you really don't have any options, right? You've taken the grind up and bury it solution off the table. Now, regardless of what the cost is, the cost of all of it's just jumped dramatically, obviously, when you do that. So now, is this new technology with a little bit of scissors cutting these crosslinks apart cheaper than whatever else would be? Maybe. It may be. Once you skew the market that way by putting restrictions in there, you have to rethink the economics, and maybe there is an economics to it. Obviously, Vestas thinks enough of it that they're going to pursue it. So that makes Vestas doesn't play around. And that's my impression of Vestas, is that they're a really serious company. And Olin's a very serious company. So you got two very serious companies and some universities that are working on this. There must be something to it, but please let us know. I think we're just going to have to follow it.
Yeah, I think that normally, like, if it's being announced, you would expect that they have it to the point where they know it's going to work eventually. But on the other hand, sometimes you do have a particular need for an announcement, and you can get pressured into announcing something that the engineers might rather not. So yeah, it's just so different to, you know, like everybody else is really pushing, like really trying hard with thermoplastics, and you wouldn't bother trying hard with thermoplastics if you had any inkling that there was going to be a thermoset solution coming up in the next decade. Then you would go that route because it's just so much structurally better and, you know, more like what we already know. So I'm I'm suspicious that this might have been announced too early. I doubt it's going to be just around the corner.
So let's ask the obvious question, which is, and Rosemary, you're the perfect person to throw this question to, I think. If you're making a composite structure and you have recycled epoxy components, does that make you stay up at night? Because it would me, and I'm not a structural person.
Yeah.
Like I'm taking these components, which may have some unique variability to them that I don't know because I don't have any history with it. Do I just reincorporate it into my next generation of blades, or is it just a ton of work that has to be done to requalify this new material?
Yeah, it's a ton of work to qualify a new material, and it would be considered a new material. They wouldn't be like, oh, we'll just throw this into, the whatever we did with the virgin material before that, because I believe that they're separating the fibers out and have the resin separately. So then they'll be, they're doing lab tests. They'll start off probably with very, very small, just fiber tests. Then they're going to probably make some laminates and test small pieces of that, lots of them, enough to get statistics and see what the variation is. And then they'll move up to, larger components and eventually real blades. So no, I wouldn't be worried about how they're going to be used in the end, but it will be a lot of time and it costs a lot of money to qualify a new material. It's also true for any, if you want to change your supplier of your glass, or your carbon fiber, you have to do the exact same thing. So I think it'll be a normal process.
Well, and would you suspect that it would be kind of like I know some plastics, like they have a certain amount of times they can be recycled, right? Like they can't be infinitely recycled. They degrade a little bit over time. Do those plastics get recycled to the molecular level, though? Probably not. I'm certainly no plastics expert, but does this seem fundamentally different than that, where this is just like, Alan, you're nodding your head, so I just want you to go.
Like you go to a DIY store. I don't know what you call it in Australia, but it's like Home Depot, a hardware store in America, and you buy some epoxy, right? And there's two tubes. There's two pieces to it. There's a hardener, and then there's the epoxy itself. You mix the two together in a whammo, right? So you get this thing. It hardens, and so you're basically undoing that and putting the solutions back into the tube again. There has to be some chemical change that has occurred in there. It can't be like virgin material. It won't be. And that's what scares me a little bit is, where that material ends up. I think the aerospace community will just say no, right? That they will just say, no, we're not doing that because we don't have a 20-year lifespan on the material. That's the timeliness part of it and how much effort and money is going to be spent into it, because you don't know what you don't know. And until you put it out in service for a long period of time, literally 20 years of beating that blade apart or an airplane apart, you're just not really confident in what's going to happen there. So even in the airplane world where we do structural testing and we have a pretty good confident feeling that this new material is going to work just great, it doesn't always turn out that way. Right. And I think just because these wind turbines are getting so massive, the cost versus the risk starts to play in. Maybe it's not worth the risk. And maybe you can break the material, the epoxy, into its original pieces, but maybe you're making something less risky with it. That would make sense to me, like making a bathtub or making some sort of other plastic
planters fiberglass planters, or like even like the shell for like a drone. Like
right.
A lot of these DJI drones are plastic. Doesn't seem structural, or moderately structural at best.
Right. Yeah.
Probably low impact. Okay. So
there you go. Or make nacelles out of them. Make nacelle covers out of them. Things that are not really structural. Yeah.
Yeah, I was just going to say there's more and less structural components in a wind turbine blade or wind turbine as well. So yeah, nacelles are a good idea. As also, vortex generators, or maybe
canoes,
inside your canoe.
Plastic slides for playgrounds.
we can already shred composites and make like boats and other, like really garden furniture, stuff like that. So I do think that this has a potential to be, like a level above that. But yeah, I don't think that the first thing they're going to do is just make a whole wind turbine blade out of these recycled materials. I think that will be somewhere down the line, but I'm sure that's their goal, right? I don't think they want to. Yeah, a lot of times what they call recycling of composites is really just finding places to hide the stuff. So like you can hide it in cement or you can hide it in landfill. It's not necessarily a huge difference between those sometimes.
Yeah, well, and it's weird that you start to think of recycling as that thing becoming that thing again, but that's probably not the way most recycling is, right? I mean, most cardboard probably doesn't become, well, cardboard might be a bad example, but most things probably become something, like you said, something lesser that's less important, less stressful. It just, as long as it finds some future life, then it's been recycled, and that works for everyone, right? So, okay, well, we'll keep an eye on it. Next up, we've got the Jones Act, very exciting United States policy, which is going to come into play increasingly more because there's a lot of non-U.S. companies like Ørsted who are big players, and there's a lot of things coming over from overseas where offshore has been, it's well established, and it's all being brought here to the U.S. So the Jones Act, which I had to read up a bunch on, is it basically, so I'll read it a little bit here. It restricts the transportation of merchandise between 2 points in the United States to qualified U.S. flag vessels. So if you're a certified coastwise qualified vessel, then you can transport merchandise between U.S. territorial waters, which are about 3 nautical miles off the coast. So this comes into play. Alan, I'll have you jump into the fray here. Where did this come into play recently, and why are people talking about this Jones Act as far as qualified versus non-qualified vessels?
So it has to do with using U.S. flagged ships. And there's not a lot of U.S. flagged ships anymore. A lot of the things are imported or exported. So the destination or the origination is out of the United States. And so they're flagged out anywhere. And if South Korea being one of the big places. But once you start motoring around wind turbine components within the states, it forces you to use essentially a U.S. ship. Now, that's not going to be the cheapest thing. Right. And what everybody starts worrying about is I got all these added costs that are coming on. I could have hired a Vietnamese ship or a Sudan ship or something to move my wind turbine from Florida to Boston. And now I can't. Right. And that's the difficulty. And there's a lot of because of the profile of wind turbines, you're going to have a lot of oversight. And because the unions are involved, you're going to have a lot of oversight. And they're going to ping you every time there's any indication you're trying to skirt the Jones Act in the United States. Someone's going to be calling the Congress person and complaining about it. So there's an inherent cost structure when you do that that's going to start escalating the costs of wind turbine installations in the States. And one of the discussions is, do we start building our own ships? I think it was Dominion Energy was talking about building a new ship just to install wind turbines with. But wow, that's odd because the United States hasn't been a shipbuilding country since essentially World War II, shortly thereafter. But we may again. And that's, so when you talk about building the infrastructure, and the U.S. can't be the only country that does this. I would imagine most countries are very strict about this. It's just like flying on an airline. Let me give you an example on an airline. If I fly from, I can't fly Air France from New York City to Los Angeles. I can't do that, right? I can only fly an American carrier to do that. I can fly Air France from Paris to New York, but I can't take a foreign carrier inside the United States. And most countries tend to be that way. So I wonder what I'm wondering is going to happen here, because the Jones Act has been thrown around a lot in the halls of Congress saying, this is the Jones Act. Hey, I can protect my state and get a bunch of jobs. But then the forces of politics come in and say, okay, the big construction companies are going to say, I don't think that's a good idea. And, laws are meant to be changed. And this is one of them that I wonder won't get changed before the offshore wind really gets big. that they'll flip it and say, well, in these particular cases, if you're more than 3 miles offshore, we don't care. You can do whatever you want. That may be what happens, because I don't see adding a lot of cost into the offshore wind right now. Just don't see it.
Yeah. So more specifically, the ruling from U.S. Customs and Border Protection, it's about the mixed use of some foreign barges and U.S. barges. And I guess what's complicated about it is that they're constructing this semi-submersible hull for an 11 megawatt wind turbine. It's being assembled in Maine, and then they've got to sort of drag it off into the water and then use this combination of foreign and U.S. Flagged barges to then submerge it and anchor it to the seabed. So that's where it gets complicated, because it's not all U.S. Barges helping to get this thing into its final resting position. And so some of this ruling was basically because the barges are used as a platform and not really transporting it. CBP is saying that they're not violating the Jones Act. And so they're going to allow the barges, the foreign ones, to move away from the dock and then come back as long as they return to the same port. And all the towing is going to be done by coastwise qualified tugs. So those are, U.S. flagged tugs. So it's not going to be like a Chinese tugboat helping to push it back out there. It's got to be a U.S. flagged tugboat. So really complicated, interesting stuff. So, with this complex issue of just getting these turbines into their final resting place offshore, I know that sounds like they're dead, but they're very much alive. Part of that process is getting the seafloor mapped, identifying, the bedrock that they're going to either be anchored to or the spot they're going to be floating above, whatever. So one company called Bedrock is using some interesting submersible drones that are going to help map the ocean floor just a lot more, what's the word here? Efficiently, number one, but they're going to provide essentially almost instant access to ocean floor data is what they're claiming, which is really interesting. So, Rosemary, obviously there's a lot of logistics, like you said, from every aspect of this, but it seems like this sort of technology, we've talked a lot about aerial drones, companies like SkySpecs and many others are doing a lot to help maintain wind turbines. But now that we're offshore, much more in a global sense with the U.S. coming into play, it seems like the submersible drones are going to probably have their day.
Yeah, actually, when I read this article, I was like, oh, yeah, that's so obvious. That why haven't we been doing that for a long time? So, obviously, I don't know why it must have been harder than it seems for it to be, just coming on now. But it does seem very useful, because I know that that's like a really lengthy part of the process, is mapping the seafloor, and not just for offshore wind as well. There's all sorts of things. Like, I've been following this project in Australia called Sun Cable, where they're going to put in a gigantic solar farm in northern Australia, plan to put a subsea cable all the way to Singapore to supply their theory is, or their idea is, they're going to supply like 20% of Singapore's electricity from the Australian desert. So, it's a very interesting project, and I've been following it because it's so like audacious. But I have noticed that, the cable length started out at, it's going to be a 3,000 kilometer cable. Then it was a 3,500 kilometer cable. And it's kind of going up and up, because as they map the sea floor, they find that they can't do the route that they wanted to do. And I'm not sure that this drone will work for that project, because I think this one only has a maximum depth of like 50 meters or something. But, as the technology improves, then I guess that it is going to help with subsea cables and anything else that we want to do to the ocean floor. So I think it's really cool innovation.
Also, Bedrock, actually, they're claiming they can operate in depths up to 1,000 feet. And they can venture off to 56 miles. It seems like 50 meters or 160 feet is about the max depth for a wind turbine where it can be installed. So it seems like Bedrock's well within that. They're excited about the tech. Alan, does this seem like this is a game changer, or is this something that's maybe still going to take a bit of time to roll out in its kind of full version?
Well, I think it's going to be a big game changer because of two reasons. One, if you can really determine what the seafloor looks like, you're going to stop a lot of damage to your cables, right? That's early on between the United States and Europe, they were always trying to lay a cable, right? So you could have the first telephone conversation and someone in London. And the difficulty they had was you'd run over these rough parts of the ocean floor and the cable would break, or there'd be a storm and it'd run over these sharp rocks and it'd break. So knowing where that cable goes is really critical, because you got so much money in the cable. Those cables are not cheap. And then you got obviously all the ships to spool them out and the whole thing. You really want to put them in even if it takes a longer route to get there, in the safest possible place for the longest period of time. And right now, you don't really have very accurate data, so they're kind of guessing at it a little bit. And I think that will dramatically lower the cost, because if you're an insurance company and you're underwriting this underwater cable, that's your worst nightmare. That a storm comes and it gets severed in half, or if they lay it across something that's particularly sharp, like an old battleship, and then blammo, the cable breaks. And I think there's an opposite side, because I think on the United States, I think another thing may happen, which is off the coast of New England, there's a lot of shipwrecks over there, from whaling ships back in the day to more modern things. And so, you don't necessarily want to disturb those, because we consider to be grave sites, a lot of them, because sailors were lost. And so you don't disturb them. And I'm wondering if also you're going to see a lot of conservationists come in and say, or national bodies like the Navy or something come in and say, this area is sacred. You can't lay cable in this area. Stay out. And the same thing also, if they determine there's some sort of reef or some underwater structure that's for animal life needs to be there.
Or the lost city of Atlantis, we might now find it, and you can't put a wind farm on that. Come on.
Well, yeah, because this relates back to, I think this technology was developed when they lost that MH370 aircraft, that 777 that went off into nowhere, and they never really found it. And you know how hard it is to find something that massive in the ocean. It's damn near impossible, which is why they really haven't found anything yet. But through these mapping technologies, it won't take long. If we get the technology right and we start deploying them and the number and quantities, I think they will. Man, we're going to find a lot of things that we thought were lost. I think that will happen.
Well, that's a really good point about that plane crash, because how many years ago was that? 3 years ago? Something like that?
No, more like 10.
Oh, was it really?
Yeah, it's been a long time.
Okay. But either way, it did seem odd. It's like, oh, we know approximately where this went down. This was a big flight. This was not like everyone knew this happened and we still couldn't find it. And that does seem crazy in today's age, that a huge plane with, debris, you find one piece of debris from this huge plane and you have a general idea of where it is now, right? But still couldn't find it. Yeah, that is kind of baffling. Yeah. So yeah, you wonder about the implications with that, with all this offshore wind. And just, camera resolutions have come so far in the last 10 years. There are still people who are, work in video who are, probably only 45, 50 years old, who were probably started out their career snipping film, right? Camera technology has made huge changes where it's smaller and more powerful than ever. We're recording on mirrorless cameras, which are rapidly replacing DSLRs. And so the things that, we should be able to do is going up a step function. And I think one of the things that's interesting here, I know, Alan, you love data. You're just such a data nerd, but they have their data platform already. Bedrock's is called Mosaic. And that probably solves a lot of problems that were also present 5-10 years ago, that even if you got all this data, or you just had a tiny little memory card, or however they would have done it back before storage what it was. So, Rosemary, do you feel like this is, do you think this will fundamentally change where we install offshore wind farms, though, or probably not? It'll probably just make it easier.
Yeah, I think it'll speed it up. I don't think it's going to solve any of the real challenge is, trying to get the foundation in place in deep water and, make sure that the cable's right. So we'll probably also be able to, what do they call it in oil and gas? Like prospect better. So, you might be able to try and test out more sites before you can choose the one that's going to be the cheapest. Because I imagine that currently it's probably not unusual to be surprised at how much it's going to cost you to get your cables in place, and maybe some foundation surprises. So I guess it'll cut back on uncertainty, and I think it'll save a lot of time which is good because the planning time frame on new offshore wind farms, it's so long. I've been hearing about these ones coming in Australia for already a year or two, and they're still, like several years away. And I'm like, I'm really keen for this to get up, but it's, so anything they can do to smooth and hasten that process is going to be really welcome, I think.
Yeah, well, I mean, even in today, where we feel like we have everything solved, there's still this crazy building in San Francisco. I'm not sure if you both have heard of it, but the Millennium Tower in San Francisco is tilting. It's sinking and it's tilting. This is like a luxury building, like, celebrity athletes. I mean, this was a really luxurious high-rise in San Francisco, and they're currently putting $100 million into it to try to prevent it from tilting and sinking. It's currently like 22 inches tilted. So, and that's onshore in the daylight in San Francisco. So then, like you said, you think of these challenges where it's pitch black at the bottom of the sea and you just don't know what you're getting into down there. Like, you can see how just difficult and there's probably so much unexpected stuff happens that the public just isn't privy to. So I think you're dead on that. This will probably make things just a lot easier as the submersible technology continues to evolve. So last on our docket here is this open hydro tidal turbine. This is at the EMEC, the European Marine Energy Center. They've been removing this from its, they've opened a tender for the removal of this turbine. So Rosemary, you're, I think, our champion of all these, not only wind power things. What are your thoughts on this tidal turbine and tidal power in general?
Yeah, well, I did a few videos on my YouTube channel about wave energy, partly just because I was surfing at the time, and I'm like, oh God, there's so much power in these waves, and like, why isn't wave power a thing? Obviously, we've been hearing about it for decades, and tidal is kind of similar, although the common idea is that it's much simpler because it looks just like a wind turbine. Like, wave energy is hard to extract the energy because you've got these like linear motions, mostly up, down, or forward, back. But tidal, it just, turns a turbine very similar to a wind turbine. So it seems like, a nice, simple way to deal with it. But when I was reading about this decommissioning and what happened to this particular technology, it was very similar to what we see with wave energy technologies. I could not find anything wrong with the technology. It seems like it was working. It was, making energy, delivering it to the power grid. They had some sales, but it was just costing so much money to develop. They were, in so much debt because every time when you develop a technology, things go wrong all the time. You need to go out and fix them. It's one thing if it's a wind turbine or a solar panel, it's sitting on the ground in some conveniently located test location. Another thing if it's in the ocean. And this site in EMEC, I think it's in the Orkneys, it's a really, really beautiful location that I really want to visit and go surfing there. It's there specifically to take away some of that pain. It's a test site there where they've got all the infrastructure in place. You just drop in your new equipment. It's very easy to do a grid connection. They've got infrastructure there so that you can easily take it out of the water to maintain. So they're trying really hard to smooth that as much as possible for ocean technologies. And yet this technology, nothing particularly wrong with it. I'm sure it would eventually work. It just costs too much. And one thing when I was talking, one of the interviews I did for the YouTube videos was with a couple of researchers from the University of Western Australia. And they said the thing with wave energy is that you need patient money. You need patient investors because it just takes so long. It costs so much money. You've got a cable break. Maybe it's an off-the-shelf cable. It's not even your thing. You've got to replace it. It's still, you got to wait for a weather window. You've got to get divers out there. It's just, you just burn through money in that early phase well before you're going to start recouping from a lot of sales. And so I think that's just, it's just another story of a technology that there's nothing particularly wrong with the technology. We could have got it to work, but it's just not economic. And I mean, I wonder, do we need these things? We're trying so hard with wave and tidal. Isn't, solar and wind and storage enough by now? I don't know.
I feel like you're the diversification person, though. I feel like that's out of character, no? I mean, shouldn't we get a little trickle from a million different sources?
Yeah, and I think so. One thing that you hear a lot when you talking about different kinds of energy technology is people say, it's not about any technology winning, we need them all. And I kind of agree, except I don't think we need them all. I think we need a variety, but we don't need all of them. Just because you can make energy from, like a shaker flashlight, that doesn't mean that that's going to be a part of our, renewable energy future. So we need a diversity, but we don't need every single idea that someone has doesn't need to be part of the final, system. Yeah. So, but you're right. I am today being uncharacteristically negative about wave because I do think that if there's any time for wave or ocean energy, it's now. But I'm still not sure that it's ever going to be their time.
I think this is interesting because this ties into offshore wind so nicely in that the maintenance is the key and how much it's going to cost to maintain these things, right? And I know on offshore wind, that's one of the big concerns is that you have to have this crew of people on a floating hotel that constantly maintain these wind turbines. And how much is that going to cost? And if these cables break and the turbine starts floating, how much is that going to cost? Though it's not just the manufacture of the component, it's what you do over the 20-year lifespan that matters here. And offshore wind and tidal energies always seem like they're synced up in this weird way, which is you're never really sure how much you're going to spend on the ocean. It's just such a rugged environment. And the seafloor changes and you got these weird things happen and you have hurricanes and typhoons and you have weird shifts in the tectonic plates and God knows what else. So you just don't know. And I think with tidal, it has kind of run its way in that the maintenance is going to kill it. You can do the engineering, you can put it out there, but just it's so costly to fix it. You can't do it logistically. But offshore wind, we're like, we'll make this work. I'm not so sure. And I think this is why companies like Bladebug, I'm losing track of who the Rope Robotics, Arones, SkySpecs, all these companies that are doing the robotics are so critical to the success of offshore wind. It's not just making the turbine and floating it out there. It's the ability to repair it, maintain it, and keep it operating. It's going to be key to making it successful.
Well, and just to close the circle here, I mean, Open Hydro was installed back in 2006. This was 15 years old. And this was a 250 kilowatt turbine. And of course, the Orbital Marine O2, which we talked about a couple months ago, that's a 2 megawatt turbine, much different design, right? It looks like a 777 airplane that you parked in the ocean. Essentially, the waves pushing its propellers. So there's that newer iteration is out there, and maybe that's more durable, maybe that's more cost effective. So there's definitely some, they've made a lot of progress. And like I said, that's a very different design that just launched this year. So, and Rosemary, I don't think for the record, I don't think you were, I thought you were being pretty charitable about it. That just, hey, this worked. It just didn't pan out financially. And I think there's probably a lot of things that have been like that, right? Where, I mean, all the older turbines were so underpowered compared to now, that maybe they just did run their course and people got data and now they know, hey, maybe with new technology and new materials, what we did learn, that one won't have died in vain and give rise to these new cool ones. Because the O2 is a really cool machine. So we might have to revisit that one. Yeah, that thing was cool. So, well, that's going to wrap it up for today's episode of the Uptime Podcast. Thanks so much for listening. Be sure to check out the show notes where you can subscribe to Uptime Tech News, our weekly newsletter with podcast updates, as well as Rosemary's YouTube channel where she's always putting out new renewable energy content. Be sure to subscribe to the show on iTunes, Spotify, Stitcher, YouTube, wherever you listen or watch. We'll see you here next week on Uptime. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.